the first thing is the logistics for the exam. It will be on Monday. It will be during class time. It is preferred that we just go up through the end of class, but I don't like to cut people off based on time, so I would have you follow me to my next class and continue the exam. That's the only accommodation I can offer for that, but please only use it if you feel you really, really need it. The next thing is what the exam will be like, and it will be, as of right now, it's set at 13 questions. It's about half and half conceptual and calculation. That may change a little bit by Monday because I am not done with it for sure, but it will be a roughly even distribution of points slash questions between chapters 2 and 3, because chapter 1 is all the stuff I wanted you to have coming into the course, and it's all things that are not really physics, they're just physics adjacent. So we will use trig in questions on this exam. There will not be a question that is just what is sine of this over that. There will also not be unit conversions on the exam because I feel like that just kind of mucks things up more than it is actually testing anything. So no unit conversions required, and really the exam technically starts chapter 2. You can have a cheat sheet, 8.5 by 11 sheet of paper, just the front, whatever you want on it, does not matter to me. There will also be an equation sheet provided. I sent out an updated version of that earlier today, and we'll probably see it again here a little bit later. I think that is all the logistics type stuff for the exam. So are there questions on that bit before I get into the actual content? All right, we will start going through this. So as I said, chapter 1 is a little bit of a write-off because things will be given in SI units, and if they're not, I will not require you to convert them to SI units. So this stuff has probably made things a pain on Wiley, but it will not make it a pain on the exam. The trig, of course, you do need for vectors, but we'll look at that in the context of vectors. The last thing that could be relevant from chapter 1 is just knowing your north of west, north of east, south of east, just what that means if I'm telling you that something is, for instance, 30 degrees north of east, because you may be given some things in that phrasing for a vector addition type problem. So the real start is chapter 2. And I think how I want to do this is to give you a sort of big picture of each chapter, and then we'll talk about the specific things that you may want to look at. So the big picture of chapter 2 is that we can define several quantities associated with motion, and some of them are what we're used to in everyday life. Speed is about what you think speed is. Some of them are very different from what they are in everyday life. Acceleration is not always what you think acceleration is. And for all of that, we use these axes. So we put some numbers to things by giving them coordinates, and we start to talk more about the effect of motion rather than what are you doing at any instant. That's the first step. And so you look at displacement. That's the change in position overall, not necessarily how you got from point A to point B. And we use that to define things like velocity and then acceleration. So I would say that's the philosophy of chapter 2, is what even is motion? How do we talk about it? And it is through these concepts of displacement, velocity, and acceleration. Now I think I can get into more detail. One thing to know is the difference between displacement and distance traveled. So displacement, it is just, I was at A, now I'm at B. It doesn't matter how I got there. It doesn't matter if it took a year or a second. It is just, I was at A, now I'm at B. What is that overall effective distance that I moved? If I run around the world and end up back where I started, my displacement is 0, even though my distance is whatever the circumference of the Earth is, I think 25,000 miles. So those can be very different numbers, and knowing which is important. Speed and velocity. So average speed versus average velocity. Primarily the velocity bit is the most important for the exam. Do you know what average velocity is? Do you know how to find it? And do you know what the difference is between it and instantaneous velocity? The difference is instantaneous is your velocity at a moment. And so if it were on a graph, a position time graph, then it would be what is your slope at a single point, right? Average velocity is the slope between 2 points on a graph like this. So you can expect questions about finding velocities from position time graphs. Direction is important. So for velocity, it's pretty easy. If it's the average velocity, it's just on average, I'm moving west or east or whatever. Instantaneous is also pretty easy. It's just which way are you facing at any particular moment. Acceleration is the difficult one. So acceleration is not just negative means slowing down, positive means speeding up. It is how it compares to the velocity. So let me get down to acceleration. The sign of acceleration is only important as far as how it compares to the sign of the velocity. If they both have the same sign, then the thing speeds up. If they have opposite signs, then the thing slows down. We happen to see both things happen if you're throwing a ball up in the air. As it's rising, its acceleration is downward, but its velocity is upward, so it slows down. As it is falling back down, both its acceleration and velocity are downward. So the acceleration never changed direction, the velocity did, and so it speeds up as it falls. That's really the important bit, is it's about their signs compared to each other. Same sign, speed increases. They have opposite signs pointing in opposite directions, speed decreases, and vice versa. If you know about the change in speed, you can figure out the directions of each. And then kinematics is really the meat of chapter 2. The idea of the kinematic equations is they're a way for us to relate all of these variables if the acceleration is constant. That means that the object's speed is changing by the same amount from 1 second to the next, and it is moving along a straight line. You can expect problems very similar to these, where you're given some information, you have to figure out where that goes in your tables. So if you like using the tables, you will need to make them yourself. I'm not going to give you a table on there. And based on that information, figure out whatever it is they want you to find. I guess whatever I want you to find. Pictures will help, and they will not always be given. There will be some pictures for certain problems, but you need to be ready to actually sketch out the situation, and that should be the first thing you do on problems that don't have a picture. Free fall is just kinematic equations, but vertical. The only special thing about free fall, but it is the most special thing that is the easiest forgotten, is this. The acceleration in free fall is always downward. It is always 9.8 meters per second per second. That means that something's velocity changes by that amount, whether it's going up or coming back down. It's just that if it's going up, you are reducing the velocity by 9.8 meters per second each second. If it's falling back down, you're increasing by 9.8 meters per second each second. And this is true for you, me, a car, anything, as long as we can ignore air resistance. And you can on this exam. There will be no part where I say, what would air do? And then very similar problems for this. You can expect ones a lot like these. And that's chapter 2. So the main things are distance versus displacement, average versus instantaneous velocity, signs of acceleration and velocity, position time graphs, and kinematic equations. Okay, for chapter 3, the broad strokes idea of chapter 3 was two things. One is vectors, and that they're useful as a general tool for physics. The other is projectile motion, and that is just 1D motion twice. So the big idea here is you can treat any 2D motion as just two 1D motions, and then you put them together to get the 2D motion using vectors. All right, so the details. The things you'll want to know are how to add vectors like this, as far as just sketching out a picture of the vectors to find their resultant, and then how to use that information to get a magnitude and direction for your resultant. So that would be the component method of vector addition, where you have to find x and y components, add them all up. Okay, so can you sketch it? Can you then find the length and direction of that vector r? Vector subtraction, it's possible it'll be on there for one question. It's not a major focus, but it is vector addition. All you have to do is flip the second vector. So vector subtraction is a plus the flipped version of b, a minus b. Components is the big part where calculation comes in. You can expect one big question on this, and it would be very similar to this one. You find x and y components, use them to find the overall x and y components for your resultant vector, tell me about its magnitude and direction. As of right now, that question is worth 14 points on the exam, so it's a larger one. Here is your sort of algorithm for doing that. Okay, and also a question like this, it's the same type of question as the last one. The main other bit of this chapter is the projectile motion part. So this stuff, but specifically applied to projectile motion, so I'm going to scroll down to that. It's a 2D motion with a couple special features. One is that just like in free fall, the vertical acceleration is always that same value, 9.8 down. Horizontal, no acceleration. That has two implications. For the vertical velocity, it works just like in free fall. You can pretty much treat projectile motion problems as free fall problems if you're looking at only the y direction. So if you want to find maximum height, you want to find the time it takes something to hit the ground, a lot of that can be done just by looking at the y components. The horizontal piece, the x component, is constant. It doesn't change. And so in my picture up here, that's saying if I find my x component of velocity, it's the same throughout the entire flight of that object. It's the y component, the vertical, that changes by about 10 meters per second each second. And so if it got over here, it'd be about 20 meters per second down. For you, it's more about applying the kinematic equations to relate what the ball's doing or whatever projectile is doing at different points in that flight. So conceptual questions for this you can expect to be related to this one. It covers pretty much all the things. Calculation questions are a lot like the ones here. So as far as the difficulty of the exam, it's more on par with the notes questions than the homework questions. And that's by design. If you can do the homework, you can definitely do the exam questions. And this last one is also good types of examples to look at. I think that is the main things. You know instantly for projectile motion, you can put these in, and then that you can say v0x and vx are always the same. That's my recap of 2 and 3. So now I'm ready for your questions.
I have a question.
Yes.
So in the quiz, there's an example where the velocity was going right and acceleration was pointing down. So would that mean velocity is positive and acceleration is negative?
I would say even more specifically, velocity is in the positive x direction, acceleration is in the negative y direction. But yes,
So would that mean it's slowing down?
it doesn't. It means that it is changing direction and eventually speeding up. And I've got some space over here. Someone did ask me to cover this question from, I think, the homework as well, so I'll get to that at some point. But for your question, we had a projectile, and it's asking about the acceleration and velocity up here, right? So up there, I can say that it is going this way, but gravity is still pulling it down while it's up there. What that's going to do is this component, Vx, it is whatever it is, 10 meters per second, 50, whatever it is. But the y component at the top is 0. Because at that point, since it's the top of the arc, it must be where the ball or whatever stopped going upwards and is going to start falling back down. This acceleration, ay, is what we say is negative 9.8. It's telling the ball, okay, I'm not doing anything about how you're moving left or right. I'm not going to change that Vx because I point in a totally different direction. I am going to change Vy in the next moment. 1 second later, Vx will be the same number, whatever it was, but Vy will now be 9.8 meters per second faster. So now I have a y velocity. Vx hasn't changed, but that Vy is due to that acceleration AY. So maybe I'll label that in green, and it's still acting here as well. And that's going to change the velocity by another 9.8 after another second.
So would that Vy be negative?
Yes, Vy is negative 9.8 when the ball is right here.
Oh,
After another second, Vx is still the same as it was before. It is whatever that number is. Vy is now an additional 9.8 meters per second down. It is now negative 19.6, about 20. And then after another second, so on and so forth. And the kinematic equations are just a way of summarizing that into one compact expression, really several.
okay, thank you.
I'm going to scoot this down to, a new page, but I'll just address this question. So let's see, we have displacement vectors adding together to give vector r. What they're saying is if you walk along A and then along B, the resultant or effect of doing those two motions, the shortcut is r. So the question is, if we know that phi is 20 degrees, now I think on Wiley, at least when I saw it for someone else, it didn't use the two different variants of phi, but this is the same angle as that. It's actually the same symbol. There's just different ways to write phi. Use that angle and the fact that it's 20 degrees to find the magnitude of the resultant vector and the angle theta, so this angle that it makes with the x-axis. All right, so this is a kind of standard vector addition problem. So I might make a table to do it. And so I've got vectors A and B. I want to add them together to get my resultant vector R. Okay, A points straight upward, so it has no x component. It doesn't point left or right. It does point entirely upward, so all 6 meters of A is along the y direction, and it's upward, so positive. For B, it points to the right and downward. So I do my signs first. Then I figure out the components of B in the x and y directions, so I'll sketch those in. This is Bx and By. So Bx, that side is adjacent to that 20-degree angle, so I'll use cosine. So it is B cosine phi, and we already said it should be positive. So this would be plus 8 meters cosine 20 degrees. That's what I put in down here. While By is negative and it is opposite that 20-degree angle, so I should use sine for that one. If I add my x components, I'll get my overall x component. So it will just be 8 meters times cosine of 20. Same with the y. It'll be 6 meters minus 8 meters sine 20. If I calculate those, give me a second to calculate. Okay, for the x, I get about 7.52 meters, and for the y, I get 3.26 meters. And I notice that they're positive. I didn't get a negative out front in my calculator, and that's reassuring because in my picture, R points to the right and up. So this is Rx, this is Ry. That's the numbers I just found. Okay, the last step is I need to get the overall length of R, its magnitude. And to do that, if I know Rx and Ry, it's Pythagorean theorem because I've drawn in a right triangle. So just putting in my values. and everything is under that square root. In my calculator, I'm not rounding them to 7.52. In my calculator, it's 7.51754. I'm leaving it as is. You don't want to round in between steps, especially with Wiley. I'm not as concerned, but Wiley is, well, it's Wiley. So I get 8.2 meters for that, 8.19549. And then the last part is I need that angle theta. I see that Ry is opposite it and Rx is adjacent to it, so I will use tangent. But if I want to find theta itself, I need inverse tangent. So I'll do that in black. Inverse tangent Ry over Rx. .26 over 7.52. And here they are both positive, so I don't need to worry about it, but I would still just ignore any signs that were there. If either of these were negative, I would not put the negative in right here because that gets confusing with what the calculator spits out. It's easier to just look at your picture and know this is north of east or south of west or whatever direction. So what I get when I put that in is, in not rounding in my calculator, all right, I get an angle of 23.47 degrees if I'm trying to be a little more accurate. And it looks like that was how Wiley did this person dirty. If you round in between steps, that rounding error accumulates, and eventually your final answer is pretty far off from what Wiley's looking for. In this case, 23.47. It may not seem that far off from 20, but as far as a percent error, it would be about 15% error. So this person probably did this question correctly, but if you round in between, it will come back to bite you. So that's it for that question. Any other questions?
I have a question.
Yes.
How do I know when to use the inverse tangent, not the other one, like the tangent, the normal one? Like
So if you're trying to find an angle, you use inverse. If you're trying to find a side length, you use the regular one.
Oh, okay, got it. Thank you.
I have a question about the practice exam.
Sure.
Could you go over 38 and 39?
Okay, so I'll just go to the answered one just so we can quickly check that I didn't mess up completely. All right, 38 and 39. Let's start with 39. Just because it's conceptual, it'll go a little bit quicker. So we have three vectors and we're told about their x and y components. And we want to know how is D related to those three vectors? So in a sense, this question is kind of asking which vector is which of them is A, which is B, which is C. And the way I can tell is from components. Usually we're used to going from looking at our picture to get the components. This is going the other way. I see that this is positive, but this is 0. That tells me that vector A points to the right, but does not point up. This must be vector A. For vector B, positive, positive. It points to the right and up. So this must be vector B. It's the only one that points in two different directions. Vector C points not left or right. It has 0x component, but it points down because of that negative. So vector C actually should look like this, but that's not what's on the picture. What must that be? Negative C, flipped over. So D is what you get if you walk along A, and then along B, and then along negative C. That makes sense?
Yeah.
Okay. And for 38, use the component method of vector addition to find the resultant of these three vectors. So when I get a problem like this, or one where I'm told that someone's walking this way and then that way, and I want to know how far away they ended up overall, my first step is I'm trying to sketch out this. And so I would read this as person walked along A, then along B, then along C. Okay, so they first walked 56 kilometers to the east. That's vector A, 56 kilometers magnitude. Then they walked 22 degrees south of east. So they looked east and turned south of it. This is east. They turned towards the south to walk the direction they walked. So something maybe about like that. It says 11 kilometers, so that's shorter than A. That'll be vector B. Oh, that's a messy B. This angle is 22 degrees. And last, vector C, 88 kilometers at 44 degrees west of south. So I look south and then turn west. So this looking straight down in this picture is looking south. You turn west from that. So it's easier if I imagine I draw a straight line for south. I turn 44 degrees west of that. And that'll be vector C, 88 kilometers in magnitude. So the resultant is start at A, take the shortcut to get straight there. So this is the vector they're asking me to find. I want to find its magnitude, and I want to find the angle it makes with, say, due east. So this will be theta. So far, so good?
Yeah.
Okay. So I will find my components. Oh, I was about to write force. These are just generic vectors. I want to add A, B, and C so that ultimately I can find the resultant R. Okay, so tell me about the components of A.
The x component is 56 and the y is 0.
Yep. So positive 56 and the y is 0. What about B? You don't have to tell me the numbers, just tell me signs.
Positive and negative.
And what about for C?
Negative and negative.
Yep, points to the left and down. So now we do need the numbers, and for that, we'll draw in the x and y components, because that's the thing we need the lengths of. So bx, it points to the right, it points down, so my arrows should look like that. Bx and by. While vector C, it points down and to the left. So I might draw, this is down, that's to the left. You may have the question, why not left and then down? I can do that instead. Either is correct. Okay, but then I would need to know this angle or this angle because those are the ones inside of my right triangle that I've drawn with those components. I can find those angles pretty easily, but since I'm already given that 44 degree, that's why I'm using those two sides instead. Okay, so that will be CY and CX. Okay, for BX, should I use sine or cosine?
Cosine.
Because it's adjacent to the 22 degree angle. So 11 kilometers cosine of 22 degrees. All right, and then for BY?
Sine.
Yep, because it is opposite that 22 degree angle. Okay, what about for CX?
Sine.
Yep, because it is opposite the 44-degree angle. It's tempting to say cosine because it's along the x direction, but that's not what matters. It's just that it is opposite the 44-degree angle. So 88 kilometers is the magnitude of C. I multiply it by sine 44 degrees. Okay, and then for CY,
Cosine.
because it is adjacent to that 44-degree angle. Okay, to get my overall x component, I add down this column. To get the overall y component, I add down the y column. All right, so if I add down the x, let me do that real fast. I get about 5.07 kilometers positive. And for my y, let's see. About negative 67.4 kilometers. And so what those numbers are representing is my overall vector r. It's telling me that it should point down because of that negative y component, and it should point to the right because of that positive x component, and it does, thankfully. So rx and ry. But maybe that wasn't the best way to draw it because I'm looking for the angle theta. Maybe I should draw them so that they enclose that angle. So I'll put Rx up here, and I'll put Ry here. It still points to the right and down, so there's no harm in doing it either way. So I'll take those out. That was a mistake on my part, but then I turned it into a teaching moment. I'll let you think about how many times that's happened already in class. All right, so I have Rx, I have Ry because that's what these numbers are. They're those two lengths. I need to put them together to get the overall magnitude of R. So the length of the red vector. Use Pythagorean theorem again. Okay, 5.07. Square that. Ry. It's negative, but it doesn't matter because it's going to get squared anyway. If I put those in, again, I'm not rounding the numbers I have in my calculator. I get 67 kilometers. Let's check if I messed up something somewhere.
I also got 67, so that's why I was confused on why the answer is 88.
Okay, 56, 11, 88 sine 44. I think all that's good. And west of south, BY and CY are both negative. I am pretty prepared to say the mistakes on my end of whatever I did the first time I found this number. So I'm going to go with 67. I think I'm with you on that. I guess it happens through the course of 50 questions, but I will fix that. And then what angle did you get?
85.7.
Okay, so it sounds like the angle is right. It's just that magnitude. And if the angle is right, that's a good sign that the magnitude is correct as well, because you're using the same numbers to find the two things. Yeah, I'm going to say it should be 67 kilometers on that. Sorry for the mistake. But theta we would find as inverse tangent ry over rx. But I would throw out the signs for that. And I'll just double check that I get the same thing. Yep, 85.7. Okay. So I disagree with myself and say that that should be 67 kilometers. I bet I probably put in a positive somewhere I should have put in a negative. So happens to all of us. I assume that clears up that question.
Yeah, it does.
Okay. Yep. Sorry again about that. What other questions are there?
There's this one questions that I emailed it to you. It's question 16 on homework, chapter 3. I did the right steps, but I was not sure why my answer was not correct.
Okay, I can walk through it. I am kind of giving away a solution to a homework problem, but I can at least sketch it out. All right, so we're told that it's launched at 41 degrees. And these numbers can differ from person to person, but it says for you a launch speed of 3.2 meters per second. And we want to know how high above the water that hits. So where this bug is. And we're told that at that point, the water is at its maximum height that it's going to go. So that's the top of the arc. And it looks like that's all the information we're given. The question is what that height is. So if you didn't, it does help to also go ahead and write out these.
Acceleration is one of them, right?
Yes. So in projectile motion, it is always the case that the y acceleration is what?
Negative 9.8.
Yes. And the x acceleration is what?
0, I think.
Yes. So when y'all see a projectile motion problem, you can think of this as your starting point. The table is pre-filled in for AX and AY. They're givens, even if they don't tell you that in the problem. Okay, what else do we have? We have V0, but not V0X or V0Y. How can I find those?
Cosine and sine.
Yes. So this is V0X. This is V0Y. The way I've drawn this, the velocity points to the right and up. So I still use positive for both of those. Then it's the magnitude, which is 3.2. For V0x, since it is adjacent to the 41-degree angle, I'll multiply that by cosine 41. For V0y, it's 3.2, and multiply that by sine 41. So those are now filled in. I ultimately want to find y. So that's my unknown. I still need at least one more known to pick a kinematic equation. So either Vy or T. Do I know either of those? So if we read the question, it doesn't scream it at you, but it does whisper it. It says that we need to assume that the point where the bug is at the maximum height above the pond surface. What's special about a projectile at its maximum height?
Is Vy 0?
Yes, because if it's the maximum height, the water's not moving up anymore. That's why it's the maximum height. It has no vertical speed at that moment. It still has horizontal speed, and it's still going to be exactly whatever it was before. So V0x, I can write for that as well. Whatever 3.2 cosine of 41 degrees is, it's still that for the horizontal. But that gives me enough, because I'll put in 0 meters per second right here. I have 3 knowns. I have 1 unknown. I'm going to let y'all take it from there to pick your kinematic equation and find it. Usually the errors with these are using this for V0y instead of finding this component of it, or not using 0 for this.
My mistake was using 3.2 meter per second cosine and both sides in the x component and the y component. That was my mistake.
Okay, so that's a small mistake in the grand scheme of it all, and it would be treated as a small mistake on an exam.
Right, thank you.
What else we got?
Number 7 in the homework 3. Can you help me draw a picture for it?
Sure. Can you read out the problem?
So a violet flies her route in 2 straight line segments.
Okay.
The displacement vector A for the first segment has a magnitude of 256 kilometers
Okay.
and a direction of 30 degrees north of
Okay.
east.
Now I feel like I have enough information to start drawing. So just so you guys hear like a real time, this is where I might start drawing. All right. So first displacement vector has a magnitude of what again?
Magnitude of 256.
256. And what was the angle for it?
30 north of east.
Okay, so I face east and then turn 30 degrees north of it. So about something like that, maybe, where this is 30 degrees and this is 256. Was it kilometers?
Yes, I think.
Okay.
Yeah.
All right, and then what do they do?
And then the displacement vector B for the second segment has a magnitude of 163 kilometers and a direction due west.
Okay, so now from that position that they ended up at from the first displacement, they go due west for 160 kilometers. Okay.
Mm-hmm.
All right, and then what?
The resultant displacement vector is r equals to a plus b, makes an angle theta with the direction due east.
Okay. So find that vector.
Yes, find r and the direction angle theta.
Okay, so how would I draw R in on this picture?
Do you connect it?
Yeah, which way does the arrow point? Up and to the right or down and to the left?
Down.
Is
To the
that the
left.
shortcut to get from her starting to her finishing point?
I think so.
Well, she starts here, right?
Yes.
She goes over here.
Yes.
So she goes that way. That would be up and to the right.
Okay.
Okay.
I meant like down as in like from 160 to 256.
Okay, so well,
Okay.
so
But
this
that's
vector.
up. Yes.
Okay, so
Yes.
that's just me pointing out this is a really common mistake is just putting the arrowhead on the wrong side, and it will
Yes.
mess you up as far as finding components and things. So it is really important to get that arrowhead right.
Got it. Thank you.
Does that clear it up for the rest? Because theta would be this angle that it makes with due east.
Yeah, it was just like hard to draw the picture from.
Okay.
Yes. Thank
Yeah,
you.
so the way I think about any problem like that is I imagine myself walking along the first thing and then along the second thing right after. And then the alternative, the resultant, is the shortcut. I start at where I started and end up where I ended up, but a shorter way, and that's the red vector.
Got it. Thank you.
Mm-hmm.
I have a question. Could we please review quiz 3?
Okay.
If you have, yeah, because the first two questions, I was just confused about them.
All right, so which question?
The first one. I got it right, but at first I was confused.
Okay, so sketch A plus B. I was given the feedback that it may have been easier if I had just written R, the resultant of A and B. Does that help in any way?
Yes, or like a plus b equals to r. I feel like
Okay.
that would have been like it would have clicked, but it made it harder.
Okay. All right, so that is what we're being asked to find, is what is that resultant? And so to find any resultant, I can imagine myself walking along the first vector, then along the second vector, or taking the shortcut. So I could walk along A, that's my first vector, and then along B right after. And you know what? Just so it's even more like one-to-one, I'll do this. I'm going to draw over top of A, draw over top of B, and I'll move those so I have like the real actual vectors. All right, so first I would walk along A and then along B. A plus B, the resultant is the shortcut. So I could just go straight from my starting point to the ending point. And so that would be this one right here. I guess it ended up a little bit angled. There we go. So if I take that vector, bring it over here, the same vector as A. All right, so for 2, it's almost the same question. It's just, and this is where it would have been, maybe you'd be confused for me to write R, because we usually say R is equal to this plus this, but maybe that's just me. But this is asking you, if I subtract A and B, what vector is equivalent to that? And so to do that, to do vector subtraction, it's really saying A added to the flipped over version of B. That's what subtraction means. And so I'll copy my 2 vectors again. This one, my trip is, I'll separate them out. So I'm starting with having no idea how to lay them out. That's kind of what this is representing. The first leg of my trip is to walk along A, so I'll just leave it where it is. The second leg of my trip is to walk not along B, but along the flipped over version of B. So let's see if I can do that. Flip it over. So this is negative B. And A minus B, the resultant of those 2 vectors is this. It's the shortcut along that direction. So this would be what we call A minus B. And that one was this, part C. I use my laser pointer as that one. Is that clear, or do you want me to say any more about that one?
It is clear, thank you.
And so, just to check, it is the same one, again, just up to some scale and like where I put my arrowheads. All right. So there's lots of small things that can go wrong with those, mainly just where the arrowhead goes on things and how you lay things out end to end. But just remember, this way of adding vectors is called either tail to head or tip to tail for a reason. It's because you always treat it as like, I go from here to here, and then I go from there to another spot. And so unless we're doing that other method where it's called the parallelogram method, where we lay them out at the same corner, I'm never expecting to see the tails of both vectors at the same spot. Now, here, it happens not with A and B, it happens with their resultant. That's a different story because the resultant is just meant to be the shortcut instead of walking along A and B. It's not laid there so you can add it to A. Okay, so if you're doing the tip to tail way, it's always tip to tail or tail to head. All right, what else we got?
There was a question that was similar to 4, and the acceleration at 4 at B, I mean, it was 0. And then the answer is not E, it's B.
So
Can you explain this to us, please?
a question similar to this where?
I don't remember, but it was not on the homework. I can't check right now.
Okay. There could be a question similar to this where it's 0 for an earlier chapter, but it would never be for the acceleration. It would be for the velocity that it could be 0 if it's not a projectile, it's free fall. The acceleration, whether you're looking at A, B, or C, is the exact same number, the exact same direction. It is the thing that's always negative 9.8, 9.8 downward. There is no x component to the acceleration of a projectile ever. It is never overall equal to 0. The velocity, you can have 0 y velocity for a projectile, and that's what happens up at the top. It stops moving upward, but it never stops moving, in this picture, say, to the right. And that's because its horizontal velocity is whatever it started as, and that value never changes. So that's talking about velocity. Technically,
Yeah,
this would
for
be.
the velocity it was clear, but for the acceleration it was not.
Okay, so what that 9.8 is telling you, since it's downward, is that all it's there to change is the y component of velocity. It's never going to change Vx. It's never going to change how fast the baseball is moving left to right. It will only change how fast it's moving up and down. And how it will change it is by 9.8 meters per second each second.
Okay, I get it. Thank you.
Uh-huh. And so just to be clear, that's why that was A for number 5, because it's asking about the velocity up here. All that's left over is the x component of that velocity when you reach the top, because at that particular point, and only at that point, Vy equals 0. Vy would be some other value here because it's still rising. It would be that same value, but negative here because it's falling. It's Vy, Vy, and then Vx is the same number every single time. Doesn't change. Any other questions?
There's one kinematic equation that I always have trouble with.
Okay.
It's well, I don't know how to say it, but it's the y equals the initial velocity times time.
Okay, yeah. So let me come over to here again. So y equals v0t plus 1/2 at squared. Are we talking in projectile motion, so 2D or 1D motion?
Projectile.
Okay, it doesn't make a difference to the equation. It's just usually we have those little subscripts if we're talking 2D. Okay, so what about that one?
Whenever I plug like values into it, I always get a weird answer. Like I'm not sure how to rearrange it for like to solve for time.
Okay. So if you're solving for time, that's about the worst thing that you can hope to solve for in the kinematic equations, because it's the one thing that requires the quadratic formula. So I can give you a general expression for it from this if we use the quadratic formula, but to do that, I have to rearrange a little bit, because quadratic formula is something, your variable squared, plus something else, your variable, and then plus c, but we do it by moving y over to the other side, equals 0. Okay, so if I subtract y over to the other side, I get that equation on the right. That's relevant because say I relabel this thing as my a, don't confuse this a with this acceleration. Maybe I'll put like a little hat on that a or something. So that, and then this is my b, and then this whole thing is c. Then this ends up looking like, with my little hat, at squared plus bt plus c equals 0. That is your standard kinematic quadratic formula. And so you can apply it. It's negative b plus or minus square root of b squared minus 4ac all over 2a. And then we can put back in what a, b, and c are. So this is my a hat. So I could rewrite this as negative v0y plus or minus square root of v0y squared minus 4 1/2. This is acceleration again, this a. And then c is negative y. Divide all of that by 2 times 1/2 a. And then I simplify out a little bit. 2 and 1/2 cancel. I've got a negative and a negative here, so that gives me a positive. 4 and 2 cancel, leaving a factor of 2. So this is negative v0y plus or minus square root v0y squared plus 2ay all over A. That is your most general formula for the time if you've got to do quadratic formula. I would not do this to you on an exam.
Okay, I was looking at one of the practice problems.
Mm-hmm.
It was saying that an arrow was shot horizontally off a
Okay.
cliff. And so I assumed that the initial velocity of like y is 0.
Yes, that does make it easier.
But then the height was 4.9.
Let me get back to what was the number for this one?
45, yeah.
Okay. So shot horizontally from a height of 4.9 meters above the ground. The initial speed is 45 meters per second. Okay, so you told me you would think the Vy would be 0 initially. I agree with that. So we would say maybe, here's your little guy. How do you shoot a bow and arrow? He shoots his arrow horizontally off a cliff. When I draw this, all I'm doing is trying to draw an arc. There's nothing special about the picture in that sense. But I agree, since it was shot horizontally, that says that my vertical velocity is none. So what must this be?
The initial velocity of x.
Yes, it's my horizontal. Because if something's moving horizontally, its overall velocity is its horizontal velocity. And so speed is just the size of that x velocity. So that's just saying if I am moving to the right at 45 meters per second, I can say that both v0 and v0x are 45 meters per second. They're the same number. Is that what you had so far?
Yeah, that's all I had. I tried to use the equation I was talking to you about, but then I erased it all because, I don't know, I messed up, I guess.
Did you try and take a square root and it was a negative number and it said you can't take a square root of a negative number?
Yes.
Okay, I can tell you why. So here is why, but we got to be kind of careful about that because I'm saying my initial point is here and my final point is here. So what should I really write for my displacement?
Oh, it should be negative 4.9.
Yes. So the arrow fell by 4.9 meters. That's the extra negative you need in order to not cause that problem. As you found, this equation is perfectly valid for this. I'll put my y's in. We found that v0y is 0, so I don't need that term. And so really I'm just trying to solve this equation. And so time is, if I solve for it, multiply both sides by 2, and then divide both sides by ay, and then take a square root. If both of these things are negative, then there's no problem. If only one is, then there's a problem. So this was negative 4.9. Ay is negative 9.8 as always. And so if you do that, 2 times 4.9 is negative 9.8. You divide that by negative 9.8, you get 1. So this is 1 second. So that is it's a good question to bring up because that is another mistake that's really easy to make and that you gloss over. And I'm guilty of it just as much. But if you're not careful with signs on problems, then you'll run into this and you'll want to erase all of your work, even though you were 90% of the way there. So signs are pretty important for this stuff. And even if you get somewhere like that, maybe don't instantly erase your work because it's probably almost right.
Okay, thank you.
Yep. Well, be thinking on questions, but if there are no other questions, I'll end the Teams call whenever we're out. But I'm happy to stay as long as there are questions.
Do we know how many questions are going to be on the exam?
As of right now, it's 13 questions.
Oh, okay, that's not a lot at all.
Yeah.
I was expecting like 30.
Yeah, no, so it's nothing like, it's not this. I've had a few people ask sometimes, like, is it going to be like this, 49 questions? No, it's just so you have lots of questions to practice on. They're usually 13 and 15 if I'm really stretching it. And it's about right now half and half conceptual and calculation, meaning multiple choice versus free response.
Out of the 13?
Yes.
Okay, that doesn't sound that bad.
Yeah. I'd rather have more small questions than a few large questions, which is what happens in engineering a lot. They will have about 2 questions worth 50 points each on some exams. I don't really like that style, so usually the points per question is 8 to 10. The largest point value is for a vector addition problem, and it is 14 points.
So will you just be taking questions from this little practice and just changing up the numbers?
No.
Bruh.
Yeah.
What's the purpose of this then?
So physics is not about being able to find just the right problem. It's about being able to take the same methods you use for any problem and apply them to a new one. So the
Oh
whole
my
point
lord.
here is just to get lots of practice with doing problems, not hope that you have the right problem on your cheat sheet.
Okay, that makes me a little bit more anxious.
So they will be very similar. I make a point of I'm picking stuff that is similar to what's in here, but I also write them myself because I know that these test banks are online.
Oh, okay. Got
Yep.
it.
And also, these questions are super boring. Mine's going to be more fun to me, probably not to y'all. All right, what else do we have? Any other questions?
In which chapter do we need to focus on?
2 and 3. The cutoff is 3. There is no chapter 4 on this exam.
Chapter 1 is just a review. I don't think it's anything.
Yes, we need those things for chapters 2 and 3, but those things themselves are not really being tested on. You just need them to complete the problems that are being tested on. To reiterate on that, no conversions will be on here because that's not physics. It's just something you got to deal with to do physics. And it just leads to more wrong answers that are nothing to do with physics. All right, if there are no more questions, then I will call it a day. And I will see y'all on Monday. So email if there are any questions over the weekend.
The exam is on Wednesday, right?
It's on Monday.
Oh Lord. Okay.
Yes.
Thank you.
Uh-huh.